So again, looking at problem 11 here, we have some data, number of hours spent studying, the student's GPA, and their score on the ACT. We want to see if there is a statistically significant relationship between these two variables, which are the independent variables, and the ACT score. So using our toolkit, I'm going to copy and paste this data into my multiple regression tab. I've got a lot of data here already, but since the multiple regression is something that you initiate every time from the descriptive statistics anyway, I'll just put this into a new tab. Doesn't really matter where I put it. This is kind of small. I'll increase the font on this a little bit. Which it didn't really do. And I'll enlarge this so you can see it. So these are my two independent variables. This is my dependent variable. So what we did in the past is we've used our data analysis toolkit, which you should find under data at the end of the ribbon. If you don't have this here, you'll need to add it, but let's assume that you remember how to add this add-in. Click on data analysis, click on regression tool. So we define the Y range, it's very slow in responding. I think the problem was in the pasting. So let me go back and type this data in very quickly. What you may have to do, it's the reason I gave you a small amount of data, 17, 20, 25, 26, 26, 2, 0, 1, 3, 5, and 5. GPA, hours, and ACT. Okay. the regression, inputting the y values, ACT, the x values. Since they're contiguous, I can highlight both columns. I do have labels in the first row. I don't need to specify the confidence interval. Wasn't really part of what we were asking for, but I'll use a 95% confidence interval. I'm going to put the output range right next door. Starting in column H. And that's all I need. So it gives me the output. I'm going to delete these columns with my original data in it now. So you can see it better. So for more than one independent variable, we would use the adjusted R squared of 0.9978. Very high correlation between the independent variables and the dependent variable. And as you can see, the p-value, this significance S, is 0.0010 to 4 decimal places. For problem 11, 0.0011 is what they have, and is what we would have if we rounded to 4 decimal places, 0.0011. So that's our significance, that's our p-value that we would share or compare with a level of significance. So this says it's very highly correlated, highly statistically significantly correlated, that the hours and the hours spent studying and the GPA correlate to the ACT score. That adjusted R squared says that 99.7% of the variability in the dependent variable can be accounted for using a regression equation that contains those two variables. That regression equation would be 2.643 x1 minus 2.179 x2. Depending upon how many decimal places were called for. And there's that regression equation. 21.5 is the intercept. The coefficient on the x value, 2.643. Coefficient on the x, so 2 value is negative 2.179. 0.643, a negative 2.179, with an intercept of 21.5.